Hello and welcome to Chapter 2, Section 1. This is Part 2 of Section 1, so we've got to work through some more examples to finish out this section. So, we talked about writing equations yesterday, taking sentences, putting them into equations, and doing the opposite. And today we're going to work on the latter half of this section, finishing out these examples. So, we know that given a sentence of information, we can turn it into an equation if we remember our order of operations. So looking here, we see the area of a circle equals the product of pi and the square of the radius r. So we can take that information and write an equation. So if I pull out my pen here, we know the area of a circle, that's just a variable. They don't give us a value. We can assign it any letter we want. Since area starts with an A, we should probably just use an A. So A, the area of a circle, equals, so equals just means an equal sign. So it's equal to the product of pi, so product means I'm going to have to multiply. The product of what two things? So I'm multiplying, it's a product of pi and the square of the radius. So in other words, it should be, I'm multiplying pi and the square of the radius. So that's radius to the power of 2. So pi times r to the power of 2. And if we look at our available answer choices, we can eliminate some things right away. So 2 pi r is not correct. Pi r, or 2r plus pi is also not correct. And pi plus r squared is not a product, that's a sum. And we're looking for a product. So for example 3, our solution should be letter choice B. So have that down for today for example 3. Easy enough. We took the information in the sentence, turned that into an equation, and now we're rolling on to the next example. Example 4a. We're asked here to translate the equation given into a verbal sentence. So now we're working backwards. Given the equation, can we write that out in words? So there's different ways that you can say the same things, but as long as you're using an operational word that is correct for the operation being used, you'll be okay. So here I would say we have the number 12. You could just leave that as 12. You see 12. Subtraction means you could use multiple words. You could say minus, you could say taken away from, you could say less than. Here I'm just going to say minus just to be safe. That's an easy one to use. So 12 minus, and I'll say 2 times x, because anytime there's a number in a variable, there's implied multiplication there. So 12 minus 2 times we could say x, or we could say some number. I'll say some, and I'll use the pound sign to mean number. So some number. 12 minus 2 times some number. We see an equal sign here, so I could say equals, or I could say is. So I'll just say is. Is, and here we just have negative 5. So I'll just say negative, and then just write the number 5. So it's okay to write the numbers. Everything else should be words, though. And if we see our solution here given with the textbook answer, we see something very similar. So if you break it down, you have 12 minus, this is 2 times x. You could say is or equals, and then negative 5. You could also say the difference of 12 and 2x. There's different ways you could say the same thing, but as long as you're on pace with the right operation, you will be okay. So that's for A, you need to have this or what I wrote down. Easy enough. So we turned the equation into words, and now we're working backwards from the examples we did previously in this section. So for B, we need to translate this equation into a verbal sentence. So again, we're working backwards. Given the letters, can we make it into a sentence with that information? So here I see we have A squared. So I'll say A squared. You could also say to the power of 2, but squared is an easier way to say that in much shorter words. So A squared, I can say the sum of or just plus. So A squared plus. This is, again, 3b. There's multiplication happening right here. It's just invisible. So A squared plus, I'll say 3 times 3 times b. We see another equal sign so that we could say equals or is. So I'll say is. And here we see c divided by 6. We could say c divided by 6. We could say the quotient of c and 6. So I'll just say, to make it simple, is c divided by 6. There we have it. So something along these lines is what we need. A squared plus 3 times b is, and then we have c divided by 6. So there we go. So we see our textbook answer here gives us a squared plus 3 times b equals c divided by 6. So there's some interchangeable things there. You could say is or equals. You could say the sum of these things, or you could just say plus. You could say quotient or divided by. So any of those would work as well. So you need to have this down. For example, for B, we turned the equation into a sentence, and now we understand how to work backwards from what we've done before. Okay, so for C, we're given 4 options. We want to translate this equation into a verbal sentence and see which one of these options is correct. So, first here, let's look at A. I see 12 minus 4 divided by B. So I know order of operations, this would be 4 divided by B, 4 over B, and then 12 minus that. Here we have 12 divided by B. This is 12 minus. So A looks very wrong to me. This says 12 less than 4 divided by B. And remember when we said less than means we're switching the order. So whatever comes first is actually going to be the second thing when we subtract. So 12 less than 4 over B would be 4 over B minus 12. So this one looks wrong too. If we look at C, we see 4 minus 12 divided by B. So that would be 4 subtract 12 over B. Well, this is a negative 4, not a positive. So I don't think that one's right either. And if we look at D, we see 12 divided by B, okay, minus 4, all right, equals, okay, negative 1, done. B is perfect. That is exactly what we're looking for. 12 divided by B minus 4 is negative 1. So there's that sentence given from the information we started with. So have that down as we move on. For D, same process. Given this equation, one of these four answers is right. So let's look at the possibilities. We see, let's look at A. 5 plus A. Okay, this is 5 plus A. There's no addition here. This is multiplication. So A does not look right to me. If I look at D, it says the quotient of 5 and A. And we said before, quotient means to divide. So we know the 5 divided by A is nowhere to be seen in this equation. We have 5 times A, but not divided by. So D is wrong. If we look at B and C, they both say 5 times A, so that's good. Equals B squared. This one says twice B. Twice something is 2 times something, or 2B. B squared, we know, well, that's B to the second power. So looking at what's given in our problem, we don't have 2B, but we have B squared. So we know answer choice B is also wrong. They try to trick you and say, we're putting in a 2. Is that the right 2 though? No. Multiplying by 2 is very different from taking something to the second power. So we should have answer choice C for this example for D. 5 times A equals B squared plus 1. There we go. Now 5A. We're asked to write this problem. Write a problem based on the given information. So we've got F is a variable. That's the cost of fries. We know the cost of a burger is $1.50 more than the fries. And we're given this expression to evaluate. So we know the cost of a burger is $1.50 more than the fries. That's what this says. And 4 times the cost of a burger, 4 times, this whole thing is the cost of a burger, minus the cost of fries equals $8.25. How much do fries cost? So this is like being the person creating the problem. So given this information, we could ask a question. So this F plus 150 is right here. We said that was the cost of a burger. So this is a burger here. Since this is the cost of a burger, that's how we got this here. 4 times the cost of a burger, 4 times the cost of a burger, minus the cost of fries, F, equals $8.25. So we could then figure out how much do fries cost by using this information if we wanted to. So what you need to have is this part here. The information given, we turned it into words, and then we asked a question. So this part you need to write down. So as we're looking at this, we can understand what's happening. They gave us a variable F, that's the cost of fries. The cost of a burger, they tell us, is $1.50 more. And then we're given this expression here, and we can ask a question about it. So that's what we did. We turned this into words right here. 4 times the cost of a burger minus the cost of fries equals $8.25. And we could figure out how much fries cost. So our last example, we were looking at 5B. We want to write a problem based on the information given. So H is a height of a girl named Tiana in inches. Consuelo's height is 3 inches less. And we're given this expression to compare them. So what problem out of these makes sense? So we know Consuelo must be shorter than Tiana because her height is Tiana's minus 3, H minus 3. So anything that says Tiana is shorter is a possibility. So D is a possibility, C is a possibility, A is a possibility, but B I know has to be wrong because it says she's taller, and that's not true. So what else do we know? We know this expression must be true, so which one of these answers has that expression right? Well, if I look at C, It says the sum of Consuelo's height and 3 times Tiana's is this 8,000 number. The sum of Consuelo's, so Consuelo's is h minus 3. The sum of that and 3 times Tiana's, or 3h, is that 8,262? Well, they said the sum of, and these things are being multiplied. This is 3 times Tiana. This is Consuelo. They're being multiplied, not added. So this one's wrong. There's not the sum. If I look at D, it says the product of Consuelo's height, okay, and 3 times Tiana's, 3h, okay, is that 8,000 number. How tall is Tiana? If I look at A, it says the product of Consuelo's height, okay, and 3 times Tiana's, okay. That looks like it could be a possibility as well. If we read what's happening here, A says Consuelo is 3 inches shorter. That's right. Consuelo is the shorter one. D says Tiana is 3 inches shorter, and Tiana, we know, is taller. So D actually has to be wrong. The only one that makes sense is A. That's just breaking down this equation given into words. We see that this has to be true. So we'll have that down as we finish 2.1 part 2. So you should feel confident in putting equations into words, making those sentences, and writing those things out.